Arabic has a phonemic contrast between plain, emphatic, and pharyngeal consonants. The ones given on the slides are just examples of some of them. So Arabic has this plain S, which is very similar to an English S. It also has an emphatic S, which is a voiceless fricative like the plain S, but with an added secondary articulation in the throat. The pharyngeal fricatives are primary pharyngeal fricatives that are made with a constriction in the pharynx. The emphatic consonants are coronal obstruents with the same place, voicing, and manner as the primary consonants. However, the secondary articulation is contrastive. For example, in the minimal pair for fig, you have a plain T, and in the word for clay, you have an emphatic T. In order to speak Arabic fluently, you have to be able to produce and perceive this distinction. Palestinian Arabic in particular, has about 4 emphatic consonants, so emphatic T, S, D, and Z, which are all indicated with the symbol next to them. The contrastive secondary articulation has been debated, so it's agreed upon that it's some sort of back constriction in the throat, but it's been argued to be either uvularization or pharyngalization. In my dissertation, I evaluated whether or not in Northern Palestinian Arabic, emphatic consonants are pharyngalized, primarily in comparison based on Davis's 1995 claims. There is likely some variation by dialect, however, so claims made about this particular dialect may be difficult to extend to other dialects. There are limited acoustic differences between the plain and emphatic consonants in the noise interval. So if you look at just the S part of a plain and an emphatic S, for example, they seem to be acoustically fairly similar, though some studies have found differences in that interval. The emphatic and pharyngeal consonants are primarily said to have effects on the formants of adjacent vowels. So it's been found that vowels next to an emphatic consonant have a lower F2 than vowels next to a plain consonant. It's also been said that emphatic and pharyngeal consonants have similar effects on the formants of adjacent vowels. In particular, it's been claimed that both emphatic and pharyngeal consonants cause a higher F1 and a lower F2 in adjacent vowels. This is most salient in low mid A, which becomes back ah adjacent to an emphatic consonant. The emphatic consonants are also said to affect non-adjacent segments of the process of emphasis spread. So on the last slide, I was talking about how an emphatic consonant like T and the emphatic T in the word for fresh would affect the neighboring vowel, but it's also been claimed that it affects the non-adjacent consonant and non-adjacent vowels, so it basically spreads throughout the entire word. This is one of the things I evaluated in my dissertation as well. In my dissertation, I conducted 3 experiments. The first experiment looked at the production of local acoustic correlates of plain S, emphatic S, and the voiceless pharyngeal H. And it also examined how these effects manifested in adjacent vowels, so looking at A, E, and U. Experiment 2 examined how the acoustic cues documented in experiment 1 influenced perception. So looking at how native speakers distinguished between a plain and emphatic S in SA and C syllables. The third experiment was a production experiment looking at how the emphatic and pharyngeal consonants affected adjacent and non-adjacent vowels. For example, where the acoustic correlates found in experiment 1 found on a non-adjacent vowels. I conducted my dissertation research in Nazareth, Israel during the summer of 2018. I worked with 35 native Arabic speakers, and it is important to note that Arabic is the primary language that's spoken in Nazareth. In my first experiment, I looked at stressed consonant-long vowel sequences in real words in Palestinian Arabic. The consonant was plain S, emphatic S, or pharyngeal H. The vowels were high front E, high back U, or low A. Within each of those categories, I measured the center of gravity of the consonant, which is traditionally how we measure fricatives. And for the vowel, I measured F1 and F2 at 10%, 50%, and 90% of the vowel duration. This allowed me to track changes over the course of the vowel. This graph shows the distribution of the center of gravity of different consonants in each vowel environment. So it shows the distribution of each consonant. So these are the center of gravities of each consonant when they're adjacent to A, adjacent to E, adjacent to U. The first thing you'll notice is that the center of gravity of pharyngeal H is much lower than the center of gravity of the other two consonants. This is what we would expect, given that it has a very different primary place of articulation. However, the emphatic and plain consonants have very similar distributions of center of gravity. This is what you would expect, given that they have the same primary place of articulation. However, it does contrast with some previous work and suggests that the primary cues to the plain and emphatic contrast are likely in adjacent vowels and not in the consonants themselves. This graph shows the formant trajectories, again separated by ah, e, and u. F1 is at the bottom of each graph and F2 is above. It's separated by female and male speakers to show the more accurately the formant values themselves. However, they show roughly the same thing. The first thing you'll notice is that F2 adjacent to an emphatic consonant is much lower, especially in low ah. So as you'll notice right here. Okay, the primary pharyngeal H did not cause F2 lowering. The F2 lowering was greatest in ah. There was some F2 lowering in E, right here, but there was no F2 lowering in U, likely because there's very little room for F2 to lower any further. Another thing to note is that the primary pharyngeal raised F1, okay, but only at the onset of the vowel, and it decreased over time. So that's observed in all conditions, even though it's a little difficult to see in the graph. The primary pharyngeal did not lower F2 like the emphatic, and the emphatic did not raise F1. So this suggests that the primary and the emphatic consonants have different effects on adjacent vowels, and it also suggests that they might not have the same share any similarities in articulation. Experiment 2 examined the perception of the plain and emphatic consonants. In order to do this, I synthesized CV syllables that consisted of frication from a plain S or an emphatic S with a synthesized vowel, E or U. Each synthesized vowel had varying levels of F1 and F2 in order to examine how F1 and F2 each influence perception of the plain and emphatic consonants. Listeners then identified each sequence as plain S or emphatic S. There were two parts to this experiment. The first one looked at perception of the plain and emphatic distinction before ah, and the second one looked at the perception of plain and emphatic consonants before E. Each graph shows the percent of emphatic responses based on the F2 levels and then divided by whether or not that item had a high or low F1 and whether or not the frication was from a plain or emphatic consonant. One thing to note is that at low F2 values, subjects generally identified consonants as emphatic. However, it did vary somewhat depending on what the F1 value and the frication. At a high F2, subjects generally identified them as plain. However, there were some limitations. For example, items that had a frication from an emphatic consonant and a low F1 were still being identified as emphatic about half the time at those higher F2 levels. So it seems that F1 and F2 and the frication all influence perception of the plain and emphatic consonant, not just F2. One interesting thing here is that high F1 values were generally associated with plain consonants, and the low F1 values were associated with emphatic consonants. There was some evidence of this in the first experiment, however, it does contrast previous claims in other dialects. This also suggests that emphatic consonants are uvularized. The frication also influenced perception, which was unexpected, given that the center of gravity had similar values in experiment 1. It suggests that there's something in the frication itself besides center of gravity that speakers are picking up on. For example, with a frication from an emphatic consonant, speakers were still more likely to identify that as emphatic than if it had a plain frication. There was a similar pattern with F1, but overall subjects had a much harder time identifying consonants as plain or emphatic. Frequently, the same subject would identify the same item as plain about half the time and as emphatic about half the time. Generally, lower F2 values were more likely to be identified as emphatic than higher F2 values, and there was an effective frication as well, where items with emphatic frication were more likely to be identified as emphatic than items with plain frication. Experiment 3 examined the effects of emphatic and pharyngeal consonants on adjacent and non-adjacent vowels. Part A examined the effects of emphatic consonants, and Part B examined the effects of pharyngeal consonants. Participants recorded control words that had no emphatic or pharyngeal consonants but contained a long vowel. The words that contained the emphatic or pharyngeal consonant had long vowels in different positions relative to the target consonant. In the adjacent condition, the vowels were immediately adjacent to the target consonant. So here's the target consonant, and there's a long vowel. So that's showing spread to the right, and here it's showing spread to the left. In the distant condition, the trigger consonant and target vowel were separated by 2 segments. And again, this happened to both the right and to the left. The graph on the left shows the effects of emphatic consonants in Part A, and the graph on the right shows the effects of pharyngeal consonants in Part B. The box plots show the distribution of F1 and F2 in each condition. F1 is at the bottom and F2 is above it. With the emphatic consonants, there were no differences in F1 compared to the control, as shown here. However, there was a difference in F2, where vowels in all emphatic conditions had significantly lower F2 than vowels in the control condition. The effects of emphatic consonants seem to extend to both adjacent and non-adjacent vowels to the right and to the left, suggesting a very strong spread. With the pharyngeal consonants, however, there was no difference in F2 compared to the control. So these are all statistically similar. However, there was a significant difference in F1. Vowels adjacent to the primary pharyngeal in both directions had a higher F1 than the control. However, this effect did not extend to the non-adjacent vowels, indicating that the primary pharyngeals don't seem to cause any sort of long-distance spread. The findings I've presented here add to our understanding of emphatic and pharyngeal consonants in Palestinian Arabic. First, emphatic and pharyngeal consonants do not cause the same acoustic effects. The emphatic consonants cause long-lasting F2 lowering. In experiment 1, this effect extended throughout the following vowel, and in experiment 3, the effect of emphatic consonants extended to non-adjacent vowels and to both the left and the right. However, the pharyngeals caused shorter F1 raising. In experiment 1, the effects of pharyngeal consonants tapered off by the end of the vowel, while in experiment 3, the pharyngeal consonants only affected adjacent vowels, with no evidence of long-distance spread. The differences in the effects on vowels suggest that the emphatic consonants are not pharyngalized in this dialect. The F1 lowering with emphatic consonants found in experiments 1 and 2 suggests that emphatic consonants are also uvularized in this dialect, not pharyngalized. Lastly, the effects of emphatic consonants were not equal on all vowels. The effects were largest on low ah and smaller on the high vowels. This also extended to perception. Listeners could more consistently identify the plain and emphatic contrast with low ah than with high front e. This dissertation provides a clear quantitative description of emphatic and pharyngeal consonants in Palestinian Arabic. This does contrast with previous descriptions, and it might be a result of dialect variation. However, it's more likely due to differences in methodologies. The data presented here can improve our phonological models of emphatic and pharyngeal consonants, as well as provide a basis for future research on long-distance emphasis spread.